The gap between AI research demonstrations and production-ready automation continues to narrow, with several projects this week showcasing increasingly sophisticated approaches to agent design. AgentStudio, an open-source project from Pseudolab, targets a surprisingly practical problem, helping users navigate complex kiosk interfaces that often frustrate less tech-savvy populations. The system employs what its developers call a VLA, Vision Language Action Paradigm. The agent captures Android screens via ADB, reasons using Gemini 3 Flash or Pro, then executes actions directly on the device. What makes AgentStudio architecturally interesting is its use of LangGraph for state management, handling the complex loops and interrupts that plague traditional automation scripts. The human-in-the-loop component deserves attention. When the agent encounters subjective choices, do you want extra napkins? It interrupts to query the user via a real-time dashboard built with the AGI protocol over server-sent events. The roadmap includes Gemma integration for on-device execution, which would eliminate the cloud dependency entirely. This pattern of cloud-assisted reasoning with local execution may prove more practical than pure edge deployment for many use cases. Browser automation remains a persistent challenge for coding agents, but Vercel's Agent Browser CLI appears to have cracked something important. Cole Medin's testing shows approximately 95% first-try task completion, compared to 75 to 80% for Playwright MCP and Chrome DevTools MCP. The key insight: traditional browser automation relies on selectors and non-deterministic matching that frequently fails. Agent Browser instead takes snapshots and provides condensed element references like ADD1 and ADD2, letting the agent decide navigation strategy. This works with Claude Code, Cursor, or anything that can execute bash commands, no MCP configuration required. Meanwhile, the Claude community is discovering that Claude skills, the ability to run code and build structured outputs within chat mode, may reduce dependency on external workflow tools. One practitioner reports spending more time building skills than creating N8N workflows or standalone agents, having successfully built social media reporting and brand identity reference tools. The highest upvoted optimization: use the LLM to figure out the process, then codify it into a Python or Node script. One user reduced Asana project management tasks to 1/10 the time by having Claude build a simple API client with templates rather than using the MCP server that had to figure it out from scratch every time. The economic logic is sound. LLM inference costs money, scripts run free. Adi Osmani's comprehensive guide to writing effective specs for AI coding agents reinforces this. Start with high-level vision, let AI draft details, use plan mode to restrict the agent to read-only analysis before execution. Hardware optimization for local AI. The local LLM community's obsession with VRAM density continues to produce increasingly baroque hardware configurations. A user running an 8x RTX 3090 system on an AMD EEC 7003 with an Asus ROMED 8 2T motherboard is contemplating a switch to 2x RTX Pro 6000 Max-Q GPUs, a decision that sparked extensive technical debate about the real-world trade-offs. The existing setup relies heavily on PCIe risers and configurations the owner describes as not pretty, including an X8-X8 bifurcator with daisy-chained risers for the 8th GPU. The results are predictable: inconsistent PCIe lane allocation, one GPU at X8, another at X4, stability only achievable by forcing all slots to Gen 3, and periodic GPU drop-offs requiring 10-minute reboots before VLM reaches readiness. The proposed Max-Q upgrade would cost approximately 3 times more, $16,648, with a calculated 7.1-year break-even period on power efficiency, assuming non-stop usage. The benefits would include NVFP4 quantization support and FP8 compatibility for models like Minimax 2.1 and GLM 4.7. The community's top-voted response suggested an entirely different path. Rather than spending $16,600 on new GPUs, invest in proper infrastructure for the existing cards. Recommendations included MCIO-based risers for cleaner PCIe connectivity, proper cooling solutions, and better cable management. The underlying lesson applies broadly. Exotic hardware configurations often fail not from component limitations, but from interconnect and thermal constraints that proper planning would have prevented. A more modest build demonstrates what's achievable within a standard mid-tower case. 3 times RTX 3090 plus a 3060 and a fractal-defined 7, yielding 72 gigabytes of usable VRAM for inference. The builder sourced 3090s over 3 months at approximately $600 each and used cheap AliExpress vertical mounts. Temperature management improved significantly once cards had gap spacing equivalent to an empty PCIe slot, a detail that matters more than many builders realize. The practical model roster includes GPT-OSS 120B in MXFP4 with 60K context, GLM 4.5 Air in IQ4NL, and Qwen 3 VL25B in TQ10, described as surprisingly good. The 3060 on a PCIe 1X riser loads models slowly but performs adequately for image generation and TTS once loaded. AI training and model enhancement. Unsloth announced techniques enabling 7 times longer context lengths for reinforcement learning, with some configurations reaching 12 bimes improvements, all without accuracy degradation. The practical implications are substantial. GPT-OS 20B LoRa can now train with 20K context on a 24GB card, while Qwen 3.8B GRPO reaches 110K context on an 80GB H100 VM in QLoRa. On NVIDIA's B200 192GB, GPU's QLoRa achieves 380K context. The improvements come from combining multiple unsloth features: weight sharing with VLLM, a standby feature for memory-efficient RL, flex attention for long context training, FP8 training support, and async gradient checkpointing. These features stack, a detail that matters for practitioners trying to maximize limited hardware. The implementation requires minimal code changes, setting an environment variable and using fastlanguagemodel.from pre-trained with appropriate parameters. Free Colab notebooks are available for GPT-OSS 20B GSPO, Qwen 3 VL8B Vision RL, and Qwen 3.8B FP8 training. Black Forest Labs released Flux, a 4 billion parameter image model that achieves sub-second generation on consumer hardware with as little as 13GB VRAM. The model unifies text-to-image and image-to-image editing in a single architecture, running on RTX 3090 4070 class hardware. Fully open under Apache 2.0, it's positioned for local development, edge deployment, and production use. The model is available through diffusers with a straightforward pipeline requiring only 4 inference steps at guidance scale 1.0. OpenBMB released Agent CPM Explore, a 4B parameter agent model designed for long horizon tasks, ranking on 8 benchmarks including Gaia, HLE, and BrowserComp. Despite its compact size, it achieves 63.9% text-only and can sustain over 100 rounds of continuous environment interaction. The release includes the full training and inference infrastructure, Agent RL, Async Reinforcement Learning Framework, Agent Doc, Tool Sandbox Management, and Agent to Leap evaluation platform. For context, this 4B model approaches the performance of much larger systems. MiroThinker 8B achieves 66.4% on Gaia, while Tangi Deep Research 30B reaches 70.9%. Developer tools and productivity. A new command line tool called PromptG addresses the surprisingly persistent friction of managing prompts across projects. The tool allows creating, versioning, and storing prompts without managing text files, with output that pipes directly to Llama or other CLI tools. The key feature is variable injection. Instead of chaining sed commands to replace template values and inject file contents, users can pass var lang equals python var code at myfile.py to render prompts with dynamic content. Prompts can be stored globally or per project, making them accessible from anywhere in the file system. It's a small tool that does one thing well: the Unix philosophy applied to prompt engineering. The speed of inference continues to reshape how developers interact with AI tools. One practitioner describes Cerebras running GLM 4.7 at approximately 1,000 tokens per second as a qualitatively different experience. The entire thinking phase completes almost instantly. My brain didn't even get the chance to lose focus. The insight is that latency was invisible friction, tolerable enough to ignore, but transformative when eliminated. The experience feels less like waiting for an assistant and more like staying inside your own train of thought. Cerebras isn't yet viable as a daily driver due to rate limits and exclusive coding plans, but the hardware approach, wafer-scale chips, suggests a potential path to democratizing sub-second inference. VectorDBZ, a desktop GUI for vector databases, received updates including Pinecone and PG vector support, search statistics, and custom embedding functions. The developer is soliciting feedback on hybrid search implementation with BM25 and sparse vector support. The project's closed-source nature on GitHub drew criticism. One commenter noted that zero-revenue closed-source tools inevitably face abandonment, suggesting the developer either open-source the code or establish a legitimate paid business model. Cybersecurity and AI Safety. Security researcher Sean Heelan published findings that should concern anyone tracking AI capabilities. He built agents using Opus 4.5 and GPT 5.2 that successfully wrote over 40 distinct exploits for a zero-day vulnerability in the QuickJS JavaScript interpreter. Both agents independently transformed the vulnerability into an API for reading and modifying process address space entirely through reading source code, debugging, and trial and error. Most challenges were solved in under an hour at approximately $30 for 30 million tokens. The hardest challenge pushed GPT 5.2 against a target protected by ASLR, non-executable memory, full rel-row, fine-grained CFI, hardware-enforced shadow stack, and a seccomp sandbox preventing shell execution. The agent's solution, chaining 7 function calls through glibc's exit handler mechanism, consuming 50 million tokens over 3 hours at approximately $50, closer to $150 running 4 agents in parallel. Heelan's conclusion is stark. Future offensive cyber capability will be limited primarily by token throughput over time rather than human hacker headcount. Anthropic's Red Team published complementary findings. Claude Sonnet 4.5 can now execute multi-stage network attacks using only standard Kali Linux tools without the custom cyber toolkit previous generations required. In testing on Carnegie Mellon's simulated cyber ranges, Sonnet 4.5 successfully exfiltrated all simulated personal information in an Equifax breach simulation in 2 of 5 trials. The model achieved this by instantly recognizing a publicized CVE and writing exploit code without needing to look it up or iterate. For perspective, Claude Sonnet 3.5, released roughly a year earlier, could not succeed at this task in any of 5 trials without specialized tooling. Trail of Bits released Claude Code skills specifically for security research, including CodeQL integration for taint tracking, SemGrep for pattern-based scanning, and Serif parsing utilities. The skills are co-authored with Claude Opus 4.5, a notable detail about how security tooling is now being developed. The combination of improving model capabilities and purpose-built security tooling suggests both offensive and defensive applications will accelerate. Technical infrastructure and performance. A debate within the Linux kernel community reveals how Rust is diverging from C in its approach to concurrent memory access. The C macros read once and write once appear at nearly 8,000 call sites in the kernel, forcing exactly once reads and writes that prevent compiler optimizations from eliding or repeating memory accesses. When Alice Ryle posted a patch series adding Rust equivalents, several Rust kernel developers objected. The objection isn't technical pedantry. Gary Guo and Boken Feng argued that read once, write once semantics are complicated, sometimes used for atomicity, sometimes for preventing data races, and this ambiguity is precisely what Rust's type system is designed to eliminate. Instead, they advocate using relaxed atomic operations from the kernel's sync module, with types like opaque that make the concurrent nature of access explicit. The trade-off: Rust code will look different from equivalent C code, potentially increasing cognitive load for developers working in both languages. But violations become compile time errors rather than subtle runtime bugs. For those working with approximate set membership data structures, binary fuse filters offer meaningful improvements over alternatives. Research from Thomas Muller-Graf and Daniel Lemire shows these filters achieve storage within 13% of the theoretical lower bound, compared to 23% for XOR filters and 44% for Bloom filters, while construction can be more than twice as fast as XOR filters. By trading slight query speed degradation, storage drops to within 8% of the lower bound. For applications avoiding expensive disk and network accesses, these efficiency gains compound. HTTP: provides a quick reference for HTTP headers and directives. the kind of fundamental infrastructure knowledge that becomes increasingly important as AI agents make more web requests. Understanding cache control directives like maxage, smaxage, and stale while revalidate matters when building systems that interact with CDNs and proxy caches at scale. Business intelligence and simulation. A tutorial on building browser-based competitive intelligence systems with WebAssembly presents an architecture that keeps sensitive strategy data entirely client-side. The RuVector WASM system ingests public signals, press releases, pricing pages, job posts, patents, earnings calls, GitHub activity, and generates competitor move predictions with evidence and timeline ranges. The system tracks prediction accuracy via Breyer score backtesting, adding graph neural network-based pressure scores for competitor clusters. The technical advantages of the WASM approach include fast vector similarity retrieval for finding historical analogs, complete privacy, signals and strategy notes never leave the browser, and offline first operation with IndexedDB persistence. The tutorial implements a full data model with CI-signal interfaces and demonstrates integration with the standard Rust to WASM workflow via WASM-Pack. For organizations uncomfortable with cloud-based competitive intelligence tools, this architecture offers an alternative that trades server-side convenience for data sovereignty. Cordum, a control plane for autonomous AI agents and external workers, takes a different approach to infrastructure. NATS for the message bus, Redis for state and payload pointers, and CAP-v2 wire contracts for jobs, results, and heartbeats. The architecture includes a workflow engine with retries, backoff, approvals, timeouts, and crash-safe state, plus least-loaded scheduling with capability-aware pool routing. Workers and product packs live outside the core repository, allowing teams to extend the platform without modifying the control plane. The 4DARE framework addresses what its authors call the attribution gap, agents that report what happened but struggle to explain why. When asked why is our customer retention rate only 56%, typical agents return metric dumps. 4DARE traces causal chains through 4 dimensions: results, what happened; process, what we did; support, what resources we had; and long-term, environmental context. The framework connects to real data sources via MCP, supporting MySQL, PostgreSQL, and Excel backends. Each dimension has explicit permission boundaries. Results are display only, process can generate recommendations, support suggests for review, and long-term provides context only.